So we're currently on reading a tree object. So that means that we should be able to run this command with our app. So basically cargo run ls tree, and it should be able to open up the hash that the SHA sum that we canned. So yes, then we just want a list of the names, right? So we want like file one, directory one, and so if I remember correctly, the way that this works is we're supposed to be able to get ls tree. So this is like the actual real get one, and it hands us something like this. This is what we want out of it. Now, of course, if we do ours, we get this panicked out of bounds. Oh no, yeah, we get out of bounds because we're trying to do some tricky stuff to like figure out where in the next chunks like things are, and that's not really working the way we wanted it to. So I think what we have to do is we have to sort of like restart some of this code and just sort of like explore what's going on inside of it. And what I'm thinking what we may have to do is like literally just look at the characters coming out. And I think that we can do that by just reading each byte, right? We can just get bytes out of this. So let's refamiliarize ourselves with what's going on here. So we have okay, so we have our ls tree. Now we're getting that option of the name only, and I'm completely ignoring it right now because the command that they're running. So we're doing this with this is partnered with Codecrafters, and so they gave me free access to all of Codecrafters, and the Git challenge is what I chose, and that hash. Okay, so args. So what they're doing is they run my command and they hand it what it's supposed to be, but I don't think they really like I don't think they try something without the name only. They're just having us recreate the name only, so I'm just sort of ignoring that. Okay, so we get what the hash is. That's this SHA sum. So that would be, oh, I also completely forgot to hand it the hash, didn't I? So that would be this thing right here. So we want that. So then what I want to do is I need to go and I need to find the directory. So the directory is in .git/objects, and then there's a directory for E. So we get the directory name, we get the directory file name, which is gonna be the rest of it. So that would be like 781 all the way through this. We open up the file and it's compressed. So then we read the file and then we decompress the file. And then I think after then, everything out after here is sort of like questionable. So I think what we're gonna do is we're just gonna delete this, and we're gonna I did not delete it, did I? Decompress. I want there. That's deleted. Okay, so we have bytes. Okay, so let's I guess like loop through the bytes, and I want to just see what happens until we crash. So let's convert them into characters and then print them out, and we'll see what we got. So let's do 4 byte in bytes. Let's convert it to a character and then debug it out. So let my character it's going to be equal to, now I don't think I can do as byte like as character, right? There was like the standard, is it standard stir from UTF-8? Oh, and then a U8. Okay, so from UTF-8 we hand it, oh, can I hand it just like the byte? I think I have to do like that. I just want one thing at a time. Now we can unwrap, and then I want this to, so it's going to crash in the first instance of it not being the right thing, and that's okay for right now. And then let's just go ahead and debug the character. Okay, and then this your temporary drop value. Oh, okay, so I can get an iter, so I don't own it. Let's, I guess, like shadow the byte, something like that. Expected a reference U8. Oh, okay, so fine. I'll take ownership of it. It'll be fine. We're not doing anything with it anyways. Okay, so there you go. No errors, no warnings. You should be good to go. So if I attempt to run this, so first of all, I still have the hash there. Okay, perfect. So I want to do a cargo run, name only, get the hash, no such file or directory. Okay, well, apparently that hash doesn't exist. So what is it? Get ls tree. It certainly thinks that, oh, name only, is this, that's a very weird, that's much better. Okay, cool. So, all right, so we get tree. So we know we have that, the header, right? So it's the tree 338, that's the length. And then we have that null, which is the \0. And then we have the mode of the first file, which is 100644. And then we see this get attributes null, and then U17, and then a J and an E. This one does not have a J and an E in it. And then it panics. There you go. Anyways, what we're working on right now is this get ls tree command. So we're trying to open up this file that's compressed. We decompress it, and then we print out each character. And this is what we see before we have a character that's not a UTF-8 character, which is super interesting that this J and E are in there, because that's not what we're working on. Now we have this U. What is U17? Is that like how big it is? Is there something that tells us like what U17 is? Not the World Cup, probably. What? A binary checksum? Maybe. Let's see. U17. This would be a. Oh, okay. Let's try that. End of transmission block character. That doesn't seem right. That's device control -1 as it overlaps ASCII. Oh, and the U codes are decimal, not hex. Right. Oh, yeah. What is 7? So 17 hex to decimal. 23. So let's try the number sign. Okay. So we get header. So like what it is, it's a tree object. We get the size, 338 bytes. We have a null ref, so we know that that's like sort of, then we're beginning with a thing. So we have 100, so we have the mode. 1 is showing us that it's the name of a file, and then it's get attributes, or it might be a directory. I'm not sure. Either like it's 1 and 4, I think, are the different choices that it begins with. Oh, the U plus XXXX is hex. Okay, so it was the first one. Interesting. So then we have, okay, so get attributes 17. So is this trying to say like it's the end of this thing then? It's the end of transaction block, but 0x11 decimal 17 is device control 1. Neither would make sense within a string outside of numbers or checksums. Oh, but this is a checks. No, this is not a checksum. This is not a checksum. Interesting. Yeah. Okay, so let's now go through this, and instead of unwrapping, let's try. Wait, no, this is a result. Okay, so let's just continue. We'll get the character and then we'll debug this. Okay, so now we're gonna handle this error, and we're just gonna say, hey, just keep on going on. We'll get the byte. Now let's try this again. Oh, I guess like you can barely see that too. Let me full screen this run. Okay, so here's what we got. So we start with our tree, 338. Okay, so we go through get attributes. We have that null. We have the U17. UB, K, and then, oh, a pound. Okay, so then a pound, and then we start again. Okay, so get ignore. Okay, so that's another file. Null, bunch of random stuff, and then an @ symbol this time. And then that's our cargo lock. And then a bunch of stuff. Oh, wait a second. It's not, okay. Then this is a U19, so this is just like a bunch of things. Okay, so like the other one, it was like a hash. Then, so like sometimes it's something within the UTF-8 and sometimes it's not. How many invalid character bytes are you skipping? Yeah, let's take a look at that. So we have, after the first one, so get attributes, we have, I guess like, so it ends with a null. So we know we can go safely from null to null when we know it's within this thing. But then it's like not safe necessarily. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 there. And then we get ignore. And then 1, 2, 3, 4, 5, 6, 7, 8, 9. Then it's 9. Okay, then we have our cargo lock. And then that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then it's 10 again. I wonder if it's trying to tell us how many skipped. No, it's not how many skipped bytes because, well, if it was like an A or something, then that would be 10, right? And an A is 10. Any byte above 0x80 would be an invalid UTF-8 character. Yeah, so I think the fact that these are valid UTF-8 characters are just happenstance. It just happens to be printed out here. But we don't, it's a little bit rough. Okay, so what if we go, what if I try, can I print out? I can print out just the hex, right? I forget how to do that. Because, okay, so we get this character. Now I'm attempting to, from byte, can I debug the actual just byte? Is there, how do I convert it into an hex? Or is that good enough? Oh, let's try it. Okay, so we have our tree. We're doing the byte beforehand, right? So it's 480, 480. Okay, I can print line byte x2. Okay, let's try that. That'll be a little bit better. So you're doing a print line, so byte x2, and at the byte, you are not, okay. What did I screw up with this? Because this opening brace, invalid format. Oh, found 2. It doesn't like the x2. I should not be calling this byte. I should absolutely not be calling this byte. This is probably screwing up because it's a type. Byte is also a type. Let's just call this B for right now. Oh, wait. You were doing, oh, byte x2 is the name of it, right? So like x2 like that, and then I could do that. It still doesn't like this 2. Put that above the let byte. Oh, okay, so hold on. I get it. We have, oh, because it needs to be just the U8. Okay, so I have a U8 and I x2 that. It still doesn't like this though. So I don't think it likes well, it's specifically this 2 it doesn't like. The X, it says it's okay. 02X, let's try it. Oh, it doesn't hate that. Let's try that. Okay, that's a good start. So we have our byte. Let's make this a little bit nicer. So let's do we use the print macro. So there's no new line. We'll add one equals that. We'll print line, and then we'll print the character out, and then that should be okay. Oh, but then this won't. If this doesn't happen, no new line happens. So okay, if we get this one, let's also print line. I'll just print line nothing. Okay, so now we can see our hex on the left. So 3338 10644 get attributes. Okay, so then we have this 00, then 17. Neither of those are 10, right? 10 would be A, right? 0A? Or am I doing my my hex wrong? Yeah, that's just A. You think it's 20 bytes? You think it's counting 20 bytes? So 20, yeah. So like, but then it's like, okay, let's try it. So this ends. Okay, so we have our get attributes. Oh no, the 00 is null. The 00 is null. Oh, but this one you're thinking is 20. No, this is a space. This is a space. Because this successfully gets into text. Here, let's to further show if it's which one is it doing. Let's add in a quote if it found it. Oh, weird. That's yeah, okay, so 20. It found it. That's a that's just a space. So then okay, we get down to 00 is our null. So we get, okay, so we see the 00, which is the null, and then we have 17, and then we get these other things. Oh, after the null byte, there are always 20 bytes for the hash. Okay, let's double check. Let's see. So here's our null at the end of the names. Then it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And then it starts with this. Did I miscount? So get attributes. So 1. Oh yeah. So this includes the 20th. Okay. And then it starts over again. Yeah. So we can skip 20 then. All right. Good eye. Good catch. Okay. So what can we do? If we have an iterator, we can skip 20 at a time then. So let's see. I think we'll have to write our own loop essentially for it, or our own iterator, but I don't want to do that. Okay, so we have 4. If we figure out, okay, so we decompress, we get our bytes, and then can I just like into iterator this from here? So now we start by going. The problem is, of course, that I want to grab out, so I kind of need this to just be a normal loop because I want to be able to skip, and I can't skip it if I'm got that here. So should we just loop this? No. I mean, kind of. Okay, so then I want the next byte. So the next byte is going to be equal to bytes.next. I probably, okay, so if we don't have a next byte, then we're out of bytes. So we should probably ePrintline. What is it? There's an exit. Yeah, process exit. We'll just exit with a non-zero exit code. Why should I do that? I should just panic if I'm gonna exit anyways. Okay, so now we have the next byte. We're gonna print that out. Okay, so we can get the next byte here. I guess also if I need to print these in, I kind of want to start throwing these. I probably need to do something like count the number of like nulls and everything else like that. Okay, so we're gonna print out the next byte. We have our character. Okay, so attempt to get the character from this. Otherwise, print line that, but we might want to, we're gonna want to handle this in a different way. Okay, so print line the character. So this should be the same thing. And then what I want to do is after the, okay, so we're gonna want to get the headers and other stuff. So this should be the exact same thing already. And then at the end, oh, okay, this will error out when we get out of bytes. Okay. You need to be mutable, don't you? Okay. So this should be exactly the same thing until we ran out of bytes. Okay, that's fine. So the first thing that I want to do is I want to take this iterator and I want to extract out this part because I don't really care about you, do I? I know that it's a tree. I know it's 338. Okay, so I want to skip until 0. Do I want to skip until it, or do I want to do I just not care about it? In this, how does it work again? Yeah, so this doesn't have like the tree, so it skips the first one. So we're gonna grab the header from this, so we know. How do I want to grab the header from the actual iterator? I know it's also TREE, so that's what, 4. Ooh, plus 0, plus a space. So that's 5, plus an unknown number of things. So it's basically we just skip until we see. Okay. So I want to like nulls, null count. So if I start that at 0, I want to loop through until I get to the first 0. So if the next byte, no, if null count, okay, so if null count is equal to 0, so we haven't seen any at all, then we're just dropping everything. We don't care until we hit the first null. So really I want to check to see if the next byte, can I do this? If the next byte is null, then I want our null count plus equals to 1. Okay, so we do that. Mismatch types, expected a U8, found a reference. Are you a, okay. Can't compare U8, okay, so how about that? So we have our next byte, okay, null count. If our null count, okay, is 0, so we haven't gotten to 1 yet, we just want to continue. If we've hit this first one, so we've now gotten to this one and we've seen it, right? So I want to continue with it. Oh, be that for a single null byte. Oh, I was wondering about that. Okay, so I just to make this easier, let's put you down there. Okay, so I want to see. There we go. That's better. So okay, so if the next byte is literally just a single null, thank you, Ms. Mizard, for that. Our null count plus 1. Okay, so then we've seen the null count. If it's null, we're done, right? So we continue. I feel like I wonder if we should match this. We're gonna have to sort of like once we figure out something with this loop, then I'll probably want to like create some functions from it. Okay, so next byte equals this. Okay, so if null count is 0, okay, so if the next byte is that, continue. If the next, okay, so I wonder if I even need to get this. If our null count is 0, so we haven't seen 1 at all, continue. We're good to go. Okay, so then we are now here. So we start to see this. Do I need to track that the last character was a null? I wonder if I should do a state machine, like a finite state machine for this. So we can check to say, we start with, we're in the header, and then we're in the mode. That might make a lot of sense, right? Like we're in the header, we're in the mode, we're in the file name, and then we're in the hash. I kind of like that, because then we can just go through that and say, okay, we're back to being in the mode, and then header again. And if we're in the header, we're just looking for the null to switch. And then once we've seen the null, we know that from the header we move to mode. Yeah, okay, I like that, because then we can use match. Okay, let's create this. We're gonna have an enum. This is what should this be called? This is gonna be our state machine for the bytes. The byte state machine. I don't the tree state. Tree parse state. Sure, why not? Well, we'll figure out something better. Okay, so we can be in the header, we can be in the mode, we can be in the file name. Okay, so header, mode, file name, and then there's the hash. I think checksum might be a little bit better, more appropriate. And then that's it. Then we just continue on and it loops through. Okay, so if we have that, how are we going to use this? We're going to start with header, right? So we're going to start up here. before our loop. So we're gonna let mute our parser. It's gonna be equal to a tree parser. We're in the header. Now, okay, so we attempt to get the next byte. I want to hand the byte to the parser. Well, actually, it might be a little bit more. Do I want to hand it to the parser, or do I want to just match on the parser? So if I match on the parser, okay, so if we're in the header, we are looking for a null, and that's it. That's all we're looking for. Match parser to null count. Yeah, so we can basically say, well, we know, okay, I don't even need the null count anymore. This is completely unnecessary for me because I can just say we're just looking for a null. So if our next byte is equal to a b like that, then I want to set it to be the next thing. I want to set it to the next thing. I'm inside the parser. I don't think I can like parser dot it. So I probably have to return a new parser. So then this case, this is going to be a parser, tree parser. Okay, so after header, we know we're going to be in the mode. So I guess like this is one of the things, like if this is what I have to do if I put the logic in here. The other thing is I can put the logic down in here and then pass in the byte, and then it can figure it out. I think you can do it on rather than before the character because they are also no ops. Which one? Like okay, so we start with all of these, and then we're getting to this 0, this null. Oh, the null character separating the sections. We'll get there, but yes, I think you're right. So this is how we know. Okay, so this thing, my vision for this is if we're in header mode, we're searching for this, and then as soon as we get that, now we say we're now in mode. we're now in mode, tree parser mode. So we were previously in tree parser header, now we're in tree parser mode, and we return that. And we don't do anything, right? There's nothing we do except just change what the mode we're in. If we're in the mode, I want to search for a space. That's what I'm looking for. I'm looking for a space. So if the next byte is equal to a space, now we're in tree parser file name. If we're in tree parser file name, this is where I want to add it in. So we need to have let our file names. If we're in file name, I want to just take the current character and throw it into file name, unless it is, we can't do it blindly, right? Because we have to keep track of when we're ending. So as soon as we hit this null, we're done. So okay, so this is going to be an if the next byte is equal to a null, then we're done, and I want to return tree parser, not header. We go back. Oh, now we go into checksum. However, if we don't, then we want to increment the file names. We're gonna push. We can just push the next byte in. This is just a vector of U8. That should be fine. Okay, so that, and then we're still in tree parser. And then for you, if we're in, okay, we reach the end, I also want to file names push in a new line. So would this be an RN or just a new line? I don't know. We'll find out. I think that this would be a little bit nicer if I threw it into the actual tree parser for logic. I think so, because then I would be able to do a self and like self change what it is as opposed to return a new one. which feels a little bit, because then what I could say is only return out if you're a file name character. That'd be interesting. Then it could be a none or a some if it's a new character. Okay, so we do that. Okay, so then checksum. Checksum. It's 20 bytes, right? So if it's 20 bytes, I want to, we always see this, and then the problem is that we don't know which one is here. So I just want to skip 20 and put us into mode. So we're gonna do a next byte. Can I not skip? Oh, it's not next byte. It's bytes. What? No. Bytes. Skip 20 bytes. And then return a tree parser. Now we're back into mode again. Yeah, skip an iterator returns a new iterator that skips those bytes. Ooh. Wait, it returns a new iterator? I was really hoping... Okay, so I'm doing bytes next. I have ownership, it's mutable. I guess I could overwrite it. We could just do bytes equals. Or I could do a countdown. Oh no! Wizard, I'm sorry about that. Of course it was code. Of course it was code. Sorry about that. Twitch chat, or specifically Nightbot, doesn't understand code and thinks that is a link. So sorry about that. Okay, but this is what Mizard was sharing. So it's for, oh, that's a good idea. We just do a little loop in here. Oh, I like it. Okay, come over here. I was doing the like alt left arrow to try to like move over to this window, which is Zelage commands. Like, no, that's not how it's gonna work. Okay, so let's do a 4 in 20. So we just want to skip it, right? So then we're just going to bytes that next. We just don't care about you. We just call next 20 times. Wait, is there a next n? No. Okay, if there was like a next n where I can just like skip through that way. Yeah, there would be. It would be interesting if there was an in-place skip. Like, it would be amazing if I could do something like skip that doesn't create, like skip in place. Which I don't understand why that feels like that should exist. I wonder if it's like something in Nightly, or if it's people are like yelling about it online. I don't really keep up to date with the rest of stuff. But this one-liner is great. Yeah, this is pretty good. This will work. You know what? It would be really interesting. I bet the compiler in production mode or release mode will optimize this into something much nicer. This makes it really easy to see what it is, though. Okay, so tree parser mode. Okay, so then we returned. Now we're in mode. Now we're in mode. And then, okay, so then I don't care about that. I don't care about that. I don't care about any of you anymore. We're just going through, and this is now grabbing and putting it. Okay, so I don't want to panic anymore. Now let's just print line. We round out of bytes, and let's break. The range. Yes. It should be yelling at me though, right? It is yelling at me. Okay, what are you upset about? You're upset because if may be missing an else class. Oh yeah, so if you're a byte, you're tree parser mode. Otherwise, you are tree parser, and you are else, you are tree parser mode. Okay, let's see if this works. So we're gonna get down to here, and at this point, I want to just print out the. I just want to print out the lines, the vectors. So let's see. We can debug. There was a way to do this, right? Where you can just like take the entire vector and convert it into a string. I could map it into their characters. Let's, I guess, debug the. Let's just debug it. Let's no need to like do anything crazy with it. Let's just debug this. Let's see what we get. That was the actual git command. Okay, so we have a bunch of stuff in file names. That's good. Now I want to take the file names and convert them into characters and then combine them in together. Except I also added in the new lines, didn't I? That's not great. There might be more of what I want to do, where I want to. We could also, this would be super interesting. Could use this pattern. Ooh, I could use this pattern in the rest of this. Okay. Hold on. I think we can do more. We could pack it into a struct. Yes, I could put it into like this tree object type thing. I'm not really sure I need to. Because I think just the list of file names might be all we need from this. So here for like, okay, so if the next byte is that, then we return that we're in mode. Otherwise, so what if I change each of these to now do like a while let sum the next byte. I don't even want this at all. We just, okay, we're in a loop and we're going through and we say, okay, hey, we're in header mode. Okay, so let's get the next byte here. While we're in next byte, if the next byte is a null character, then I want to return out that we're in tree parser mode and we break out of this loop. That doesn't seem, well, is that right? Otherwise we don't return anything at all and we're good to go. And now we just write 4 sequential while loops. Mismatch types, expected a tree parser. Oh, I have to do the outside. Oh, shoot. That's okay. Hold on. That's the problem with this, is that I have to break out of the loop. Let's see. Do I want it just a loop? Hold on. Let me put this back. Do I want this just to be a loop? Just to make it a little bit easier, because I need to be able to get this byte out. Oh, label loop and break loop. Oh, yeah. I don't think I've used labels before. Like not seriously. I think we looked into them a while back, and then I just never have used them. Can I do that with while loops too? Wait, is that even a point of doing that with a while loop? Any loop. Okay. I'm trying to think. Do I put how do I put the loop in here? So like, okay, we're in header mode. If we're in, okay, so I think we're going to have to put this logic down here in the tree parser. And then what I could do is I could run the tree parser in a loop, and it gets each file name out each time I run through it until the end. So in this loop, I do like parser.run and then hand it the bytes iter, a reference to the bytes iter, so it doesn't take ownership of it, a mutable reference to the bytes iter, and then it will return either a none or a sum with a file name in it. Yeah, a step. Yeah, we can call it step. Okay, so if we come back down here, we'll just do a impl tree parser. We're gonna do pub function step. We'll take mutable reference to self, and we'll take in the bytes iterator, which is going to be a mute bytes of that, right? Wait, no, I can pass it the actual iterator. That is the into iter. Is that what I want, or do I want? I can hand it the. Oh, into iterator is a private type. Oh, okay. So then let's just hand it the bytes. Okay, so you get a mutable reference to the bytes like that, which is fine. Okay. Do I need a mutable reference to the bytes? Probably not, right? We're going to turn an option with a string. So we'll start with a to do while we're building this out. So, all right, back to what you are, so that everything is happy. I do a loop. I don't do this next bytes. I just want to do let some, I guess like this will be the file name. Did that pull something in? Yeah. So our parser step, we hand it the bytes. If we've got nothing, that doesn't mean anything, right? Okay, yeah. So this doesn't mean anything. If we're, it's either a sum because we got to the end of we got a file name out and we got it. So okay, so we get this. Now we can just do file names. I'm gonna push a file name. Wait, no, that's wrong. Nope, that's wrong. That's better. Okay, so parser step. Okay, so why are you upset? Mismatch type expected to reference U8, found a reference to a vec into iterator. Oh, because I just want that. Okay, so else. If we don't have anything here, I don't really care, do I? So, okay, so then we push our, oh, except, I do care. Oh, wait. In here, we're gonna check. So, if matches, okay, so it's me first ones, that will be the parser, and then the second thing is going to be the tree parser. I need it done. So if you're done, okay, so if matches parser and tree parser done, then we're going to break. What was this again? I know we're in that one loop, so I don't think there's a problem here, but let's just do it anyways. It was label : loop. Okay, so this will be the like loop. This will be parse file names is the name of the loop, and I want to break parse file names. Okay, so that okay, so else goes down there. So if matches, oh, because like if it doesn't match, I want to continue. Else continue. Oh, cannot find value. Oh, use the, oh, it's a like that. That's how we do the thing. Okay, so can I also continue? There we go. That's really cool. Yeah, I didn't notice you had the single quote. Hold up, shouldn't this be a regex problem? I mean, okay, yeah, we could do regex with it, but we're not. All right, so that's okay, so if matches, break, continue, parse file names. Okay, so at this point in time, we have the file names, so we're gonna file names push file name. Okay, so then there we go. Now, you get all of you. I don't want you to do anything. I want you to go away, and then we're gonna do this. We're gonna do this all over again, but it's gonna be easy. It's gonna be great. Nothing can possibly go wrong. Let's see. Parse with nom might be better than with regex. I have never used nom. Yeah, let me add in. Check out nom. Check out nom crate. Unicode segmentation. This crate provides grapheme cluster, word, and sentence boundaries according to Unicode standard annex number 29. Oh, interesting. Yeah, but you like seeing the manual implementation? Yeah, so like if for example, this was done in a coding interview, I would assume that the interviewer would say, okay, great, that's a good idea to use nom. Can you show me what you do if you didn't have access to nom? Like that's how you would get around it as the interviewer. If the interviewee was like, hey, I'll just use nom. You're like, great, that's really good that you know that. Can you please now also show me that you know how to code? That's sort of like what you do. It is seeing the different crate options that people share though. And it's good to know that they all exist. Okay, we're looping through you. Do file names push. Okay, so now we're going to implement step and have it do what we want to do. All right, so we step. Okay, so we have our bytes. I want to okay, so now we want to like basically do our loop. So we want to let's just start with a loop, and we want to get the next byte. So let our let byte equals bytes.next. I first need to get, oh, interesting. Okay, so I need an iterator from this. So wait, this actually isn't quite so easy. Hold on. If I could hand it the iterator, that would be better. I think I can. Can't I? Like I can do some kind of iterator for this and hand it an iterator. Surely I could. Okay, so we got you. So if I, instead of handing you the bytes, let's go back into, we have an iter. If I give you an iter mute, you've been finding it exciting to realize how good Rust is at gluing open source projects together. Any like in my experience, any language that has a really good community that's interested in that kind of thing ends up getting it, which is always really nice. Okay, so it's you I want. So now our bytes, can I have this be an iter mute? I can have this be an iterator. Oh, wait, can I have this do anything in impls? So it's like impl, iter mute, iterator. So would this be a mutable reference to something that impls iterator? Okay. And so now I want to get the next. So let's do our loop. Let's let our next byte equals to bytes next. Is there any way I can tell you what you are? Can I do something like item equals? So you're an option. Okay, so we can just do a let some. How do I get hair in my mouth? I have no idea. That's Zilby hair. That's what it is. Okay, so next byte. Okay, so we have our next byte. So that's obviously a byte, but then I need to tell. Can I tell you what you are? So you're gonna be a. I just want you to be a U8. This pattern has two fields, with the corresponding tuple struct as one. Oh, is it tuple? Wait a second. What? The next byte should be that thing. Okay, so next byte, I wanted to do like that, which is a U8. Oh, wait. Is it something like this, where it's like, this pattern has two fields, but the corresponding tuple struct has one field? Okay, so hold on. That's not what I want. It would be really cool if I could set what the type is for this iterator coming in. I'm not sure exactly how to do that. But okay, so if we get out of here, I want to do an early return a none. So I want to loop through. I want to do this entire thing over here, right? So I want to say tree parser. Okay, so we basically get the next byte, and then we check to see if you're a. Oh, we're gonna have to match on self to see what we are. So okay, so we'll also do a match on self. So if we're a self header, then I want to loop through until we have the first null. So loop through until we have a null. So we're gonna loop. We're gonna get a byte. If we get none here, that's a huge problem. So we should return none and possibly even panic at this point in time, because we absolutely should not return. Okay, let's panic. So we're gonna panic and we're gonna say unable to get next byte in header. Okay, now I have the next byte, which is gonna be an item, which it doesn't know what this item is, which is unfortunate. I need to. Is there documentation on how to use this? Oh, can I do something like that? So I think I can do the thing where I set the item, right? Can I do that here where I say item is going to be equal to a U8? Missing match. Okay, so missing all the match arms. Let's fill those. It's not yelling about other stuff yet. It's just yelling about this right now. That's okay. Okay, so we get to the next. Oh yeah, and we're getting type hints now. Okay, so we get our next byte, which is this U8, which this might be a reference to a U8. I'm not trying to take ownership of it. Okay, so then, okay, so panic. Otherwise we get to this point, so we have the next byte. I want to check to see if this next byte, okay, so if next byte is equal to null, if it's equal to null, then I want to do self, oh right, I do this, I dereference self equals self. We're now in mode, and we're gonna break, we're gonna return a none, which breaks out of the loop. Okay, unknown. Okay, so when we're trying to pass in, I want the iter mute. Okay, expected a mute of unknown, found an iter mute expected and unknown. Okay, so can I tell you what you are at the beginning here? I am trying to tell you what you are at the beginning here. Yeah, I'm trying to say like, hey, you're gonna get this. Oh, can I say like, that doesn't seem right. Let's see. I don't necessarily want to give ownership of this. This doesn't seem right. Okay, slice iter mute is not an iterator. Okay, expected iter mute U8 to be an iterator that yields U8, but yields mute. Okay, hold on. We're slowly getting someplace. Okay, expected a block. So, oh yeah, a block would be helpful. How did I not have a block? Did I accidentally delete that? Match pub function. This is the function step, and this is the impl, right? Isn't that right? Okay. Anonymous lifetimes and infiltrator unstable. Okay, so it needs an actual lifetime. Okay, we can. Do I put it as the function or here? I don't remember. And then we're not returning anything with that. Cannot mutate immutable variable bytes, which you are. Oh, okay, so I need you to be. Oh, and then that makes it not know what that is. Okay, so I need. Can I make you mutable here? Okay, expected a semicolon. Can't compare mutil U8 with U8. Okay, so next byte. So I don't need you to be a mute. This is all I need. I just need to mutate the bytes itself. So I don't need this. We can just do an into iterator. Expected. All right, so we're gonna do that. Send back into iterator. It is not an iterator. The trait iterator is not implemented for. Oh, how do I? Okay, so if I take bytes in, I do. I mean, I could do iter like that. No method name next here. You're right. There is no method name next at this point in time. Okay, so if that continue. I don't think we're doing this. We're finding this push and then we're done, right? Okay, so now we're on to this. So can't compare the byte. So this is a can't compare a reference to a U8 with a U8. This is the reference to the U8. So this is just a U8, right? Next byte. Now you are. I do that. Okay. Oh, and then just a ton of warnings. Okay. Okay. No, like no errors. That's a good sign. Okay, so if we're the next byte, we change our own mode in and there, and we return a none. So then we're in the none, so we continue, right? Let me save that to a jump list, and we'll go up here and we'll add this to a jump list too. Okay, so let's go. All right, so now I can jump back. Of course, it comes down way down here. So we have our step function and our parse file name. So you are, just to verify what this is, we have our break parse file names. Yeah, okay, so we're not done, so therefore we're continuing. Excellent. So I want not loop, step. Okay, next up, we're in the header. So when we're in the header, all we're looking for, if we go far enough back, we'll see what we're looking for. So, oh, weird. We just did header. Okay, we're in mode. When we're in mode, we're in this thing right here. So I want to look for a space character, and then we're in file name. So we want to, yeah, okay. And this was a loop that we were doing here. So I want to loop through another loop. We're going to get the byte. So let's byte. Otherwise, okay. So if we don't find it, there's another panic. Unable to get next byte in mode. Obviously that exits out. If our next byte is equal to a byte space, then self is going to be equal to self file name. So now we're in file name mode, and we're turning none. So we're good to go. Go on to the next step. Otherwise, keep on going through this. Okay. If we're in file name, if we're in the file name parser, then every character I want to stuff into a vector of characters. Actually, I can just turn this into a char right there and just add it and push it to a string, can't I? So this can be our file name. So that could be just a new string. Why? A new string. I want to loop through. So another loop. We're going to let some next byte. Now every one of these, we have the things to get attributes, and then it's a null terminator at the very end. So that's what we're looking for. So if we get the next byte. So okay, so if we don't get a byte at all, that's a problem. So therefore another panic. Okay, so panic error. All right, so this is gonna be error unable to get next byte in file name. Okay, so we get that. We now have the next byte, which means that I want to convert this into a character and then append it to the string. So can I do that? Can I just do next byte as character? Like, oh, look at that. There's an ASCII alphabetical. Alphanumeric. We could have done that too. Oh, that's cool. I didn't realize that we had that. Okay, file name appends a given string slice onto the end of this string, but that's a stir. Appends a given char. Okay, so I want to push this. So what is it? A stir standard stir. No, from UTF-8. Was there one that's just from byte? Like, I don't think so. From UTF-8 is that thing. Okay, so let our bytes byte equals byte. Mismatch type is expected to set type char found a result. So let's just unwrap you because why not? Expected a char found a stir. Oh, you're a stir. Okay, so this is a push stir. So I want to push stir like that. And then your byte expected a reference of U8 found a reference. What? Oh, reference to okay, that makes you happy there. This is all like light blue because it's all this is unreachable. Any code following this match. Okay, yeah. So it's yelling at me about this. Okay, there we go. But now much nicer. And then that. Okay, but I never end file name stage. Okay, so we loop through here. So unable to get the next byte. I need to check. So I need to check to see, okay, if the next byte. So if the next byte is a null, then I want to do self is now going to equal to self. Okay, after file name, we go into checksum mode. We get the checksum, and then we're going to return a none. Okay, if we get to this point, we get the byte, we push it into the file name. Oh, no, wait, this is not what I want to do. If I want to break, so we're breaking out of this loop, then here, now we can, now we can do self, okay, so we push a file name. Okay, so if the next byte is that, we break. Okay, so at this point, we are now at mode, no, we're now in checksum. So self is now going to equal to self checksum. And we want to return a sum and a file name. Yeah, okay, so we return early. Okay, we'll go with you. Okay, why am I doing this? So if I try to do this thing, so take a look. We have self. Self is, if we look at our signature here, self is a mutable reference to self. So I want to essentially change what state we are. So I want to change us from, one arm of the enum to another arm. The problem, of course, is that this is a mutable reference to self, and I'm trying to change it to like an owned new version of checksum. So if I dereference it here, I'm basically saying, okay, Rust, go to the place, like don't go to the reference, go to the place in memory that the reference is, well, referencing, and wholly replace it with this thing on the right, which is just the new checksum. So that's why I'm doing that, is I'm fully replacing itself with this new version of the enum. It's one of my favorite tricks when using enums, is that I can now just I can basically say, okay, do this thing, and now you have a completely different arm of the enum up where you're calling it, and it just works. Sun's out-of-band management was simultaneously amazing and infuriating. Yeah, that sounds about right. Okay, we get that. Return some checked file name. Okay, we're good to go. Okay, so if we're in checksum mode, we're just gonna wait. We're just gonna skip 20, right? So for that in 0 to 20, then we do